participants already, so start talking.
Here we go. Okay, good. We got people. We're live. Okay, welcome everybody to the Mars helicopter presentation today. I'm actually Captain Larricq. I got promoted accidentally to major here. I actually should be becoming a major pretty soon, but I'm still a captain, and I teach aerospace in the Civil Air Patrol. If you're not familiar with that, when we get to the end of our presentation, I'll tell you a little bit about it because it's a real exciting program to be in. The excitement today, and hopefully all of you have gotten to see that, is the Mars 2020 mission, which made a successful landing onto Mars. And I know a lot of people watched that live. I certainly did, and it was really exciting, and happy to say that the rover made it onto the surface of Mars successfully. And that's good for me because what I'm going to talk about today is the helicopter that's part of that mission. You can kind of see it in the background there, the Mars helicopter Ingenuity. That's what we'll be talking about today. And when we get through talking about that, we're going to make a little paper helicopter here. Hopefully, if you haven't downloaded and printed the template for that, maybe you could do that while we're talking about things, and we'll make that together here later in the session. Okay, so I will, since I can't see you, I'm going to turn the chat thing on here. Go ahead, I'll try and keep an eye on the chat thing. So, oh, I see a couple of you already are in CAP. That's excellent. So if you have any questions while I'm going through this, go ahead and put them in the chat and I'll try to answer everything for you. Okay, so first off, let me know in the chat if you did watch the landing on the TV or on the computer of the Mars rover. That was really an exciting deal there. So, okay, so let me, I'm gonna, okay, I do not have screen sharing enabled here. Can you please change that for me? Okay, sorry, this is the first session here. We're still trying to figure out how to get things set up.
You should be good to go now.
There we go. Okay. All right. Let me, I got to make sure I add the sound and optimize here. Okay. So here we go. Okay. Mars Perseverance rover. Okay. It's now sitting on Mars. And I'd like you to meet Ingenuity. This is the helicopter that's currently nested underneath the rover, and hopefully in the next month or so, they will be flying this, and it will be the first time that we've had a flying craft on another planet. This is from about a week ago. I did this presentation for our cadets last week. This is a diagram of the craft as it was on its way to Mars. And at that time, it was 276 million miles from Earth. It actually had to travel almost 300 million miles from Earth to get to Mars. You can see its speed relative to the sun was almost 50,000 miles an hour. So it was going real fast. Here's a picture. If you could be flying through space and looking over its shoulder, this is what it looked like as it was trying to catch up to Mars. And you can see in the red line there with the circle, that's Mars circling around the Earth. And the Mars 2020 mission craft is chasing it down. And we launched this last July when Mars and Earth were very close in their orbits. Every 2 years, Earth and Mars kind of orbits become close, and it's an optimum time for sending a mission from Earth to Mars. And in fact, just last week, there was 2 other missions that were launched about the same time, a little bit earlier. The United Arab Emirates Hope mission arrived on Monday, and the Chinese Tianwen mission arrived on Tuesday. And both of those craft successfully inserted themselves into orbits. It's really difficult to get to Mars and get into orbit. Historically, half the missions that have been flown to Mars have either missed, not gotten into a good orbit, or just crashed and were not successful. Of course, most of those were a long time ago. Nowadays, with our modern technology, things are working a little bit better. So if you watch this, you already know about this, but if you didn't, the entry, descent, and landing into Mars, the EDL, is nicknamed the 7 minutes of terror, because it takes about 7 minutes from when the spacecraft first starts to enter into the Martian atmosphere and goes through it and finally touches down on the ground. So I'm going to briefly go through this here and just kind of show you. At the very top here, you can see it's connected to the spacecraft, and about 10 minutes before they separate, and then the lander portion comes down, it starts coming into the atmosphere. Now, even though Mars' atmosphere is only 1% as dense as Earth, it's still an atmosphere. And when you have a spacecraft coming in at 5,000 to 6,000 miles an hour, it's going to rub against those molecules and it could create a lot of heat. So you can see here on the 4th frame that the bottom of that is getting real hot, and it's got a special disc on the bottom of it that is designed to absorb that heat and keep the spacecraft inside cool. In fact, it's kind of like a clamshell, because the top is also helping keep that spacecraft cool. So it gets through the atmosphere. It takes a few minutes to get through that, and during that time, it slows down to about 1,000 miles an hour. Okay. At 1,000 miles an hour, it deploys a parachute, and they spent years developing a parachute that would work at 1,000 miles an hour. It was not an easy task, but obviously it worked today, and the parachute then slowed it down a bunch more. Once it knew it had a good parachute above it, it dropped off that little heat shield, and then once the heat shield was away, the ground radar could turn on, because it had to look and see where it was going to land. Okay, so as it drops, you could see when the parachute comes out, its descent slows a little bit, and at a certain point, I think about a couple thousand feet above the surface, the landing craft actually separates from the upper dome and the parachute, turns on its little rockets, and gradually lowers itself down till it's about 30 or 40 feet above the surface. And then it drops the rover down on a cable. And as soon as it senses that the rover has touched the ground and there's no more pull on the cable, it cuts that and it flies away, and it crashes away from it so that it doesn't interfere with the rover itself. So it took about 7 minutes from the time it entered the atmosphere until it actually touched down safely on the ground. And if you watch the people in the mission control, you could see it was dead quiet, a lot of nervous legs twitching and breath holding. And they were reading off each milestone as it got through these phases. Everybody would clap when it made it through the heat, the aero maneuvering and braking, and then when the parachute came out. So they were quite happy when it finally touched down successfully on the surface. So here's what it looks like right now. The helicopter is actually attached to the bottom of it. They're not going to drop it for a little while. They spend quite a while after a craft lands on another planet, and they're going to have to do a bunch of system checks and make sure everything is working on the rover before they start messing with Ingenuity. So the team that runs the Ingenuity is now they're just biting their nails waiting for the rover to get through all its stuff to where they can start doing their experiments. And when it finally does fly above Mars, this is what it's going to look like. Okay, so I've got a little video here to show this. I'm just going to keep quiet and let you watch for a minute.
There's a question as to where you get the template, and it's in the Woova app when you go to your talk.
Oh, thank you. Yeah, I can't see the questions right now. So, okay, so there it is. That's what it will look like. Hopefully we will actually have video of this because there's really good cameras on the Mars rover, and you could see it was tracking that when it took off. Let's look real quick at what that rover looks like. Now, this thing weighs only 4 pounds. It had to be super light, and it's got really giant propeller blades in relation to how big it is. They're made of carbon fiber, and they'll spin at 2,400 RPM, which is actually very fast for a helicopter. Now, a lot of you say, oh, what's the big deal about this? I'm sure a lot of you have your little drones that you fly around, and they make them every different size. And on Earth, in our atmosphere, it's very easy to make something like this to fly. The trouble is, what makes a drone or a helicopter fly? Well, when these blades spin, they have to push against air molecules, and they have to do it fast enough and hard enough to create enough lift to get whatever its weight is off the ground and flying around. Well, on Mars, the density of the atmosphere is only 1/100th of what it is here on the Earth. So that means there's only one molecule compared to 100 for the blades to be beating against. So they spent 7 years trying different prototypes and working in vacuum chambers that they reduced the pressure down to the same as Mars to try and get this to work. And so it's quite a feat. One was just getting blades that would work, and then making it small enough and light enough that it could actually lift and get itself off the surface. Underneath, you can see that it's just got a little box with legs. Okay, the box holds batteries and some electronics to control itself, an antenna, and of course it's got a solar panel to charge up its batteries, and then 4 very light little carbon fiber legs. Okay. Here's the specs on it. Like I said, 4 pounds on Earth, but on Mars, the gravity is 3/8 of Earth. So its actual weight on Mars will only be about 1.5 pounds. And the length of the rotors is 4 feet. So you can imagine, I've got a little DJI drone that weighs about 0.5 pound, and the rotors are only about 3 or 4 inches. So this has 4 feet long rotors to get 1.5 pounds off the ground. Now, it's not going to go very high or very far. It's not going to go higher than 15 feet off the ground. It can go as far as about 1,000 feet away, but I listened to one of the team members of it talking about this just a little while ago, and they said it probably, they're not going to let it go very far away from the rover. The whole mission of this is to prove that you can fly on Mars. It's not really designed to go out. Probably the next evolution, when they create future helicopters for Mars, they'll be bigger and more sophisticated, so they could carry equipment that they will be able to look down the road where they want to send the rover to, so they can look ahead and make sure that the path that the rover is going to take will be safe for them. Or maybe they'll be up next to a cliff where they want to go up and look at a cliff where they can't climb up and get to. So future helicopters will be more sophisticated. But right now, this one, its whole mission is just to prove that you can fly a craft on Mars. Okay, and there's a picture of hopefully what we'll see. It might not be for another month or so before they even get this thing out of the garage and get it ready to fly. But that's what it's going to look like. They have their schedule is to do, they hope to accomplish 5 flights within the 30-day Martian day period of time that they have. Okay. Now, hopefully they'll get to do more than that. This thing should be able to recharge itself. It's got solar panel, and you know, I'm not sure how long it takes to charge up enough to do another flight, but I'm sure as long as it keeps working and as long as they have daylight to keep charging it, they will keep flying. So they hope to at least do 5 missions, and they usually set their bar pretty low for those. The first rovers that were sent to Mars back in 2001 were only supposed to work for 90 days. And I think Opportunity ended up working for 9 years and went over 28 miles. So hopefully they'll get a chance to fly this a lot more than 5 times. That's a long way to go to only fly your helicopter 5 times. Here's some of the milestones of the mission. The first 2 are checked off. Well, actually, only the first one is checked off. They survived the launch, the cruise to Mars, and the landing on the red planet. So the next milestone is to actually have it drop down from the belly of the rover, unfold itself, and the next trick is to keep warm because Mars is very cold. It's further away from the sun. It doesn't have a thick atmosphere to hold in any heat. It shows there, you know, at night, minus 130 degrees Fahrenheit. That's really cold. So hopefully it won't freeze up. That's why they want to do they've got a 30-day window of Martian days that they want to try and get this thing to fly. Okay, 5 things to know. Hopefully, if you remember anything from this, this is the first test-powered flight on another planet. You know, we don't get too many firsts anymore. It seems like everything's been done, but this is another first. First time flying on another planet. Remember, the rover is very, very light. Even though it had to survive the launch, which shakes it up, a very long, cold travel of 300 million miles, the harsh Martian environment and surface. It only weighs 4 pounds on Earth, but it had to be very light and strong. Again, we talked about how much power it needed. Those motors, the motor in there to turn those 2 giant propellers, have to work really hard in order to lift that off in such a thin atmosphere. When it does fly, it's not going to fly for long. A minute and a half is all they expect the batteries to last, which sounds a little, not quite as long as some of the drones I've had. Seems like the batteries are lucky to last 3 or 4 minutes sometimes, but so I'm sure some of you are familiar with that if you have drones. But 10, 15 feet in the air, you know, they're going to be very cautious this first time because they don't want to lose, they don't want to have an accident first time they fly it. So they're going to be very conservative. But remember that the Wright brothers airplane only flew 12 seconds on its first flight. So they're going to go eight times longer than the Wright brothers on their first flight. And the last thing is really important. When you fly your drone here on Earth, you're controlling every movement. Ingenuity is going to fly itself. It has to be autonomous because Mars is so far away. Right now, where Mars is relative to Earth, it takes 11.5 minutes for the speed of light to get from here to there. And if we tried to control it, it would be, by the time you told it to stop, it would be too late. It would take 11 minutes for that signal to get there. So it has to fly all by itself. So it's pre-programmed to do certain things on its flight. And they can probably, I think they probably send software each time to tell it what to do for each flight, but it's basically pre-programmed and then it has to fly itself. And they won't know until 12 minutes later if everything went right, okay? Because they will be able to watch it, but they'll have that time lag, okay? Same thing for driving the rover. They actually have to tell the rover, send a command, and usually they take little steps. They tell it to go 3 feet and stop. And they do it little tiny bits at a time. And with a rover sitting on the ground, that's not a problem. It can stop what it's doing anytime and not have a problem. But something flying can't just stop in the air. It has to be spot on, and all the software that controls that has to be just perfect. Otherwise, it's going to crash and the mission will be over. So last thing, I want to leave you with a quote from Leonardo da Vinci, who back in the 1500s, I believe, correct me if I'm wrong, you could see that picture there, was the first person to describe a helicopter. And that's one of his original drawings. And if you see, if the letters below looks funny, he wrote backwards so that people couldn't understand. He was kind of secretive, and he actually wrote backwards in a mirror, I think, so that he could kind of keep what he was writing secret. But you can tell from the picture what he was trying to design there was basically a helicopter. Of course, they didn't have the technology then to really make it work. But he said, once you have tasted flight, you will forever walk the earth with your eyes turned skyward. For there you have been, and there you will always long to return. And I bet never in his wildest dreams did Leonardo da Vinci, could he imagine what we take for granted now of helicopters that we fly around our planet in, let alone a helicopter flying on another planet. So that is, that's the end of our little presentation on Ingenuity. So let me check now. I couldn't see the chat. I can see that now. Okay, so he wasn't trying to keep it secret, but he was left-handed, so he wrote backwards not to smear the ink around. Okay, maybe that's why he did it. Who knows? We weren't real around then, but it's a good story. All right, so I hope if all of you have one of these printed out. Oh, I got to put that. There we go. This background. All right. You know, I'm going to probably have to turn my background off so that you can see. Control background. Let's see. How do I do none? Well, I'm not sure how I turn it off. I know how to turn it on. Okay, well, I'm talking about this. Get out your template and a pair of these scissors. And what you want to do is cut around the dotted lines. There's two. You can make a couple of them here. Cut around the dotted lines. And then there'll be one cut up the middle between A and B there, and we'll cut those. So I'm going to give everybody a few minutes to cut those out. Yes, you can use any scrap piece of paper, and you know what I'll try to do. Let me see. I'm going to try and put this up on the screen. So if you don't have a template, it's pretty simple. You could cut one out. Let's see here. Okay. Let me put this up on the screen. Okay. All right, so if you don't have a template, you could just take a piece of paper and you could draw this just in a few seconds. It doesn't have to be exactly to dimension. You know, if it's a little longer on the one side or the other, it's not really going to hurt it here. A and B are the helicopter blades, and though one folds one way, once you cut this out, you're going to fold on those lines below the A and the B. And one will fold one way and the other one will fold opposite. So the two blades will be opposite each other. X and Y, you just fold into the center to try and make the middle a little bit stronger. And then the bottom part Z, just fold that back up against X and Y once you've folded them in. Okay, when you're done, it should look, I'm not sure if you can see this. I'm going to stop share for a second. Okay, it should look like this. And while you're working on that, I'm going to try and figure out how to turn my background off so we can see it fly, because it's not going to work too good here.
If you click the start video section, you can choose your virtual background and edit it from there.
Well, I'm in that, but it doesn't have none as a choice. It's got a bunch of, it's got several pictures plus ones I put in, but it doesn't have none. Oh, there it is, none. I had to scroll up. Okay. All right, thank you. There we go. Now you can see it, right? There we go. I'm going to unpack this. This is how it looked when it was cut out. Where's my camera? Just cut around the edge, cut the top out. One folds one way, one folds the other. Then the sides, the two sides, fold across each other. And then the bottom just folds up. Okay. Now I'm gonna throw this up a little bit. Hopefully it will come whoop. Come here. Oh, okay. It doesn't want to start flying until it gets closer to the ground. There we go. Hopefully you can see that. It does work. Here we go. I even made a successful aerial recovery there. So this is your basic helicopter. Now, it doesn't, a helicopter would have a motor and would power it and make it go up. So this is really kind of a just a gyrocopter, because the wind, the relative wind, hits the blades and makes them spin. And there's basically a tree that has a seed that looks just like this. I don't know if any of you have seen them before, but I think whoever designed this must have gotten their inspiration from the nuts from whatever tree that is, because nature figured this out. A tree evolved over time with nuts that it created that would drop off the tree and fly, and the wind would catch them, and you can see them flying through the air when it's breezy. If you see one of those trees, and they can fly a long ways away and drop their seed and spread that species of tree around. So that's one way nature devised to spread itself around. One way is just have birds eat the seeds and then fly somewhere else and pass them through, and they drop out this way. But it's pretty amazing that nature came up with a helicopter as a means to spread its seeds. So we really can't take much credit for designing this, because it was already designed in nature a long time ago. Okay, so you can play with this. You can experiment with different designs and stuff. And something cool to show, you can, if you can make a bet with people, you could say, I can make a piece of paper into a helicopter. They'll probably say that you can't do it, and then you could whip one of these out and make your cool little helicopter there. Okay, so that's we're almost out of time here. I hope you enjoyed what we showed so far. The last thing I would like to tell you about, I'm going to share my screen here, and I'm going to show you the web page for this is the Civil Air Patrol Squadron that we're in. This is actually a picture of a day we went to the Ninja Gym. If any of you are interested in flying, there's no better way to get into flying than to join the Civil Air Patrol. You can join when you're 12 years old. From 12 to 19, you can become a cadet member. It's very inexpensive. And in the Civil Air Patrol, we do all kinds of cool things, including flying. And in fact, this picture here, the fellow right, that last picture, the fellow right in the center, 2 summers ago, the fellow on the right here is another one. We've got 4 cadets in our squadron that almost were ready to solo flying sailplane glider when they were 14 years old. Okay, so you can actually fly sailplanes when you're 14 years old. Okay, the one in the glasses in the middle right there was almost ready to solo in a sailplane. So I'm going to put this website in the chat here, and I hope you'll all copy that down and go take a look. I know I've got a few people that already are part of CAP. So if you're already a CAP member, put a little chat in real quick and tell everybody else how much you enjoy it and what squadron you're with. But we look forward to having maybe some of you join. There's several squadrons in town, depending on what part of town you live in, or even out of town. We have squadrons all over the country. If you're joining us from anywhere outside of Albuquerque, you can just look up Civil Air Patrol squadrons, and there's a squadron in most any town. So it's a really great program, and hope some of you will. We've got a great squadron if you live in the northeast part of town, but there are other squadrons around that you can join if you want to find one that's a little bit closer. So I hope you got excited today. This whole mission to Mars has myself and a lot of other people excited. I hope you got excited over it too. And I hope you'll be watching for when Ingenuity actually does get to fly on Mars sometime, hopefully in the next month. So keep on looking up and fly high. All right, and we got a couple more minutes here. If anybody has questions, I'll look at the chat, and thanks for joining. If you have any questions, I'll hang out for a few minutes and try and answer you there. Okay, thank you for all the thank yous. That was awesome. All right, why is Mars called Mars? I don't know how many years ago, hundreds if not thousands of years ago, people looked up in the sky and saw that red planet, and they named things in the skies for Greek gods, and Mars was a Greek god, I believe, and I think that's, and maybe because it was red, I think he may have been the god of war. I may be wrong on that, but someone correct me if they know better. Yes, god of war, there we go. Okay. So that's why. Good question. All right. What else? Have I fly? Yes, I'm a sailplane pilot. I've been flying since 1987. In the Civil Air Patrol, we have both powered planes and gliders, and you can learn to fly. If you join the Civil Air Patrol, you automatically get a bunch of, we call them orientation flights, in both a powered plane and a glider. And we fly we go down to, if you're in Albuquerque, we go down to Socorro to fly the glider. The powered plane, we fly out of the airport here in Albuquerque or Santa Fe or Socorro, whatever towns you're in. The squadrons have powered planes usually. There's a lot more powered planes, and in fact, the Civil Air Patrol has the largest private air force in the world because we have so many powered planes. Okay, can I post the link? Okay, link to what, please? KK Lou, what link would you like me to post? Rovers on Mars. Let's see, Spirit, Opportunity, Curiosity, Perseverance. There was a couple Rangers back in the 70s. Let's see. There's probably 8 to 10 rovers on Mars. Most of them are dead now. Yes, you can leave anytime you want. So don't hang around if you want to move on to the next thing. Like I said, the Spirit and Opportunity, Spirit and Opportunity were designed to work for 90 days. And I know Opportunity lasted, I think, 9 or 10 years before it finally went to sleep. It couldn't. Those were powered by solar panels, and there was a big dust storm, and it got real dusty, and it was cut off the sun for a long time, and it finally got so cold it ran out of power, and the mission had to end. So good question. All right, any other questions? Yeah, the only link I mentioned was the one for our particular squadron, but there's links there that will get you, if you're not in Albuquerque, through that page you can find links to find a squadron near you, no matter where you are in the country. I don't know how many, Roland, do you know how many squadrons there are in the country?
There's a lot, but you can go to gocivilairpatrol.us, no, it's .gov.
.gov.
I believe it's .gov. And you can go and see all about Civil Air Patrol and find out where there's a unit close to you. And tomorrow we have another Civil Air Patrol presentation about parachutes and parachuting to Mars.
Oh yeah, I got to plug our other. Okay, tomorrow another senior member, Lieutenant Bryant, will be doing parachute activity, which also ties into the Mars landing, because we talked about that parachute that had to work going 1,000 miles an hour. And then on Saturday, Colonel DeWing will be doing paper airplane and a presentation about something about that. So I hope you'll join us for the other 2 Civil Air Patrol sessions. Do you have anything to add to that?
Nope.
Is that it? GoCivilAirPatrol.gov?
Yes.
Okay. All right. So try that. Oh, I could tell you a lot behind the physics of this copter, but we've only got 1 minute left. So there is a ton of information. Just go to the NASA website and the Mars 2020 mission page, and there's a sub page that has all the information you want about the Ingenuity and what it took. It's really interesting, all the things they had to develop to make sure it worked. Okay. Let's see, another notification. Oh yeah, yeah. Well, if you've watched the Perseverance landing today, everybody was cheering. All right, I'm here alone in my office, and I was jumping up and down cheering too. So there were a few that landed on Mars that didn't work. I know a Russian Voshchod mission actually made a landing, but then didn't do anything. So yeah, there's been a lot of missions that didn't work, but most of those were back in the 70s and early 80s. Nowadays, the technology is pretty good. It's a lot better than it used to be. So you know, but we still don't take it for granted. If you watched all those controllers at the mission, JPL mission there today, you could see how nervous they were because they were not taking that entry onto Mars for granted by any means. So, okay, gang, well, that's it. Well, thank you, all 24 of you who are still hanging on there. We are out of time, and I could talk for the rest of the night, but I think there are other sessions to go to now. So I hope you enjoy all the STEAM events that are being put on in this, and hope you'll join the couple other Civil Air Patrol ones. There will be one tomorrow at 3:15 again, and then Saturday, I'm not sure, I think it's at 2 o'clock. So I hope you all learned something and get excited about aerospace. And if you're interested in anything aerospace, there's a lot of great work opportunities in aerospace, even if you don't particularly want to fly. Come join the Civil Air Patrol. Okay, we look forward to seeing you. And thanks again, everybody. Okay, I think they're finally drifting off.